Welcome to this presentation. Today we're going to look at question 12 of Step Paper 1, 2001. Let me read it to you. 4 students, Arthur, Bertha, Chandra and Delilah, we'll call them A, B, C and D, exchange gossip. When Arthur hears a rumour, he tells it to one of the other 3 without saying who told it to him. He decides whom to tell by choosing at random amongst the other 3, omitting the ones he knows have already heard the rumour. That's slightly misleading, because suppose it was Bertha who told Arthur in the first place, then Arthur will not tell Bertha again because he knows that she knows. So he's only going to choose between Chandra and Delilah, so he's choosing between the other 2 in that case. Anyway, to continue, when Bertha, Chandra or Delilah hear the rumour, they behave in exactly the same way. The rumour stops being passed around when it's heard by a student who knows that the other 3 already have heard it. So we're told that Arthur starts a rumour and tells it to Chandra, and we're asked, by means of a tree diagram or otherwise, show that the probability that Arthur rehears it is 3/4. And then we're asked for another couple of probabilities as well. So we're strongly advised to do a tree diagram, so let's do that. Let's do exactly that. So we'll start here. And Arthur starts the rumour, so Arthur tells it to Chandra. And what does Chandra do? Well, Chandra is going to tell it to either Bertha or Delilah. Now we've got to pursue each of these. What does Bertha do? Well, Bertha, having just got it from C, is going to go to either A or D. And let's follow what's going to happen here. What's A going to do now? Well, A has now given it to C and heard it again from Bertha. Only one thing to do, and that's to give it to D. And this is the first time D's heard of it. So he thinks it's new news. She does, Delilah. So she goes on to either B or C. And now let's think of B. B at this point heard it from C, gave it to A, has just heard it from D, there's no one else to tell it to. That's the ends of that. What about C here? C has heard it from A, told B, and is now hearing it back from D, so that's the end of that one. Let's look down here at what happens in this branch. So A has given it to C, to B, to D. D doesn't know who else has had it, tells A, not B, or it could be C. And if it's A, well, A, there's only one thing A can do here, and that's tell B. Because A has heard it from D here, and told C in the first place, so it's only B still to be told. Now what about B? B, in this branch, heard it from C, told D, just hearing it again from A, so that's the end of that. That's the end of that one. What about this one, this last branch here? C has just heard it from D, and C heard it from A before and told B, so there's nobody else there. That's ended there. Now I'm going to stop the recording because I need to make this other tree, and it's really just the same, so I'll just do that and pick up in a moment. Welcome back. I've just finished the bottom part of the tree, and now I'm starting to write probabilities on the branches, and this is very uniform because all the cases are binary. There's 2 possibilities, equal possibilities, probability of half, except where there's no choice at all when it's a probability of 1, but everything else is a half. So I'll just take a moment to fill all of those in. That's 1, that's a half, that's a half, 1, that's a half, it's a half, it's a half, it's a half, that's 1, and I'll just change colour again. Now what I want to do is to go along the tree and work out the probability of that complete branch, and you do that by multiplying along the tree, because it's an and the probability. So this is the probability that A tells C, who tells B, who chooses to tell A, who tells D, who tells B. If you look along that branch, you can see that it's an 1/8. Half times 1 times a half. And if we take the next branch, it's a half times a half times a half times 1. I think I took the wrong branch there. That was an 8. This branch is a half times a half times 1 times a half. In fact, this is kind of, even the shorter one is a half times a half times a half. They're all an 8. So I'll fill those in like that. So each branch is an 8. Now, what are we asked for? We're asked for, first of all, what's the probability that Arthur rehears the rumour? Well, this is simple now. We've done the hard work. We've just got to look at which branches does A appear again. A appears at the very beginning. Which of them does it appear again? And that's 1, and that's 1, because here is there. And then on this third branch, we go into A again, so here's there. But on this fourth one, it doesn't hear there. It doesn't go. That's A, C, B, D, C. Stop. A doesn't rehear it. So let's come down. A, C, D, A. So both of these branches, A rehears it. And on the very bottom one, A, C, D, B, A, D hears it, or finishes it, C doesn't hear it. So 6 of the 8 he hears it, 2 of them he doesn't hear it. The probability of rehearing is equal to 6 over 8, which is 3/4. So that was the first thing that we had to do. The second thing, let's do each of these in a slightly different colour. What do we have? That colour there. So now we're looking for what's the probability that Bertha hears it twice. So now I'm looking for probability that Bertha hears twice. So how many branches has 2 B's? The first one has, the second one does not. The third one does, so that's yes, no, yes. This one does not. This one does not. Neither of the next 2 do. Neither of the next 2 do. So I'm looking along branches to see whether B appears twice. Let's look at the very last one here. It's A, C, D, B, C. So B appears once. That's why I've got a cross there. Total here is 2 out of 6, which is equal to 1/4. And now we've got one more to do. We'll do this one in brightish red, I think. So now we've got the probability that C hears twice. So now we're looking for branches where, maybe that's not bright enough colour. Let me go to, no, I'll stay with that. So C hears twice. Well, C appears here on all of them, and then on the top branch, no. And we put a little cross there, and there's C appearing twice. Not that one. Yes, that one. There's C twice. C doesn't appear twice there. Doesn't appear twice there. Does appear twice again. How many ticks do I have? 1, 2, 3, 4 ticks. So that's equal to 4 over 8 is equal to 1/2. And the reason I'm adding those up is because those branches are mutually exclusive, and therefore I can add the probabilities, and I'm adding 4 of them. That's 4/8 is equal to 1/2. So the answers to the last 2 questions are 1/4 and then 1/2. Okay, that's the end of this presentation. See you again soon.